Well, as we go into this next section, we're going to continue on to 6.2. This is a bit of a starter here, and then we're going to get into dividing monomials. So we have some boom cards here. This set you might need to wait until after this little input. So here's some equivalent ways of writing 10 to the 4th power. So 10 to the 4th power, yeah, we can write it 10 to the 4th. But then you can do 10 to the 1st and then 10 to the 3rd because the same base, you add those exponents. Or powers of pi, you multiply. So now I want you to write as many expressions as you can have for the same value of 10 to the 6th. At least 3. At least 3. So they might include something like x, or excuse me, not x, 10 to the 0 times 10 to the 6th, because that would be 1 times 10 to the 6th. You might have 10 to the 3rd times 10 to the 3rd, because it would be 3 and 3 is 6. Or it could be 10 to the 3rd squared, because 3 times 2 is 6. And then keep on going. So there's 3 of them, and you can add more. Next step, number 2, I want to, which expression does not belong? State your reasoning. Well, I would suggest that you simplify each. So evaluate each. Evaluate each first. So 2 to the 3rd power is 8, because 2 times 2 times 2. This is 8, and this is 3 times 3, which is 9. And this is 2 to the 2nd and 2 to the 1st, which gives me 2 to the 3rd, which is 2 times 2 times 2, which is 8. So 8, 8, 8, this is 9. So 3 is different. It does not equal to 8. That's my reasoning. I rewrote this down below, so let's go ahead and take it down here. So now we're getting into dividing monomials. So when we divide monomials, I want you to think about PEMDAS written out like this. When I multiplied exponents, I added them. When I divide, I'm going to subtract. So basically, this is going to be x to the m minus n power. So over here, if I were to take the 6 minus 4, it would be d to the 6 minus 4, which gives me d to the 2nd power. Now, to show why that is, basically, I wrote out 6 d's, 1, 2, 3, 4, 5, 6, and I've got 4 d's down here. D divided by d is 1. 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 So I end up with d times d, which is d squared. Another thing you can do is you can say, where do I have more? It's a fraction. So where do I have more? Meaning top or bottom of the fraction. And then by how many? So basically I said I've got d to the 6th and d to the 4th. Where do I have more? Top or bottom? Well, top, because there's 6 of them. How many more? Well, 6 minus 4 is 2, so d squared. Now down below, we're going to simplify each expression. As we simplify each expression, doing the same thing. This is going to give me 10 to the 9 minus 2, which gives me 10 to the 7th power. Or I could have said, where do I have more? Top or bottom? Top by how many? 7. This one I have y to the 10th over y. This is to the 1st, so it's y to the 10 minus 1. So my answer is y to the 9th. This next step, I've got -4 and -4 both on my inside of my parentheses. So it's to the 7th power and to the 4th power. So if that is to the 4th power, I'm going to say, where do I have more? Top or bottom? Top by how many? 3. So it's going to be -4 to the 3rd power. And then I can simplify that saying 3 negatives is a negative, bring it to there, so it's 4 to the 3rd. This means the same thing. I could have said -4 to the 7 minus 4, which is also that. This next one, number 4, I have bringing this 4 to each one, so it's 1 to the 4th over 3 to the 4th times 3 to the 12th. This is actually over 1, so over 1. And any top can be reduced with any bottom. Keep that in mind. So 1 to the 4th, oops. 1 to the 4th power is 1. And so on top, I now have 3 to the 12th over 3 to the 4th. So if I were to write it up here, I'm running out of space. 3 to the 12 minus 4 gives me 3 to the 8th power. Remember, you can always pause, try these on your own, and then come back to me. So using the quotient rule to simplify the following monomials. So we're just going to keep going with this 5 and 3. So I'm going to say what I have more, top by 2. So x to the second power, or x to the 5 minus, oops, I can't tell if that's a 3 or a 2. Looks like a 3, so minus 3. There you go. The next one looks like it's an 8 and a 3. Gives me x to the 8 minus 3. Gives me x to the 5th. Or where do I have more, top or bottom? Top by how many? X to the 5th. These are the exact same. Anything divided by itself is 1, right? So we know the answer is 1. Or I could say m to the 4 minus 4, which is equal to m to the 0 power, which is also 1. Down below here, I've got a to the 6th and a to the 2nd. So I want to take each chunk one by one. Where do I have more, top or bottom, on the a's? Or I could say a to the 6th minus 2, b to the 4 minus 3. A to the 4th, b to the 1st. Another way of doing that is I've got 4 extras on top. I've got 1 extra on top. And then write a to the 4th, b to the 1st. Same thing. The next one, I've got 6 divided by 2, that is 3. And then I have an extra a on top, or x on top. So this is going to be 3, and then x to the 4th minus 3 is 3x to the 1st. I've got 14 divided by 7. 7 goes into 14 2 times. And then let's work with our variables. So I've got 2x squared minus 1, y squared minus 1. So 2xy. Now plug B. Continuing on, I've got negative 36 divided by 4. That gives me negative 9. My a's are the exact same. So I've got negative 9, a to the 2nd minus 2nd, b to the 5 minus 3. That gives me negative 9, a to the 4th. Excuse me, not a to the 4th, excuse me, minus to the 0 power and b to the 2nd power. Anything to the 0 power is 1, so negative 9b squared. On h, I'm going to keep it as a fraction. 4 divided by 8 is actually 1/2, so 1 over 2. I have more n's on top. I've got n to the 5 minus 1. That's going to give me n to the 4th on top. I could write this as n to the 4th over 2, or as I have up above. I've got 36 and 54. I believe 9 goes into both of them. That'll be 4 and 6, but then it keeps going. So I believe it's going to be 2/3 if you reduce that fraction. I've got more x's on top by 6 and more x's on, or y's on top by 3. I'm going to have 2x to the 6th, y to the 3rd over 3. Now this bottom part, these last 5 problems are going to be putting it all together. So we're going to do one step at a time. So work with the top, then the bottom, and reduce, basically. Work with the top and the bottom, then reduce. So on the top I have, and use PEMDAS, of course. So I end up with 3 squared a to the 10th over 27a to the 3rd. 3 squared is 9. Now 9 over 27, 9 goes into 9 once, 9 goes into 27 3 times. So now I have 10, a to the 10th over 3a to the 3rd. But I have a's on top and bottom, so I can reduce those. And minus 3 gives me a to the 7th. My answer is going to be a to the 7th over 3. B, same idea. We're going to distribute this 3 to each item. So it's going to end up being 2 to the 3rd, a to the 15th, b to the 12th over 4a squared b to the 7th. Well, this gives me 8. I've got a different color for you. 8. Now 8 divided by 4 is 2 on top. 15 minus the 2 here gives me a to the 13th, and 12 minus 7 gives me b to the 5th. Now the next two, I can do something on the inside of these parentheses, so let's simplify it first. So do the parentheses first and then work with those exponents. So on the inside, 12 over 15 reduces to, divided by 3 is 4, divided by 3 is 5, and x to the 5th over x, there's 4 more up top, so x to the 4th. So I now have 4x to the 4th over 5 raised to the 2nd power. Bring that into each item. So I'm going to end up with 4 squared x to the 8th over 5 squared. 16x to the 8th over 25. And the last one, do the inside first. So I end up with 4. My a's cancel. My b's, I have 1 extra one up top. So I have 4b over 5 squared. So 16b squared over 25. So it's going to go to each item. And the last one, find the missing exponent, the question mark. The big thing is look at your variables. I've got 3 times what gave me 12, and 2 times what gives me 8. Hopefully they're the same number. And hopefully you see that that's 4. Then we have boom cards on the quotient property. You should be able to finish all the boom cards up through number 7, I believe, 5.7. And then we'll start in with the notes for 6.3.